Hi everybody, in this video I want to go over the latest changes, which are having the drones fire back at our player. And as you can see, when the player dies, when they get hit, then the stage resets. The player disappears and the game continues to play for a few seconds before resetting. Now also, there are a number of changes that I've made to the game that I think have made it a lot better. And I want to go through them step by step, not just the code for doing the drone lasers, but also all the changes and why I did them. So you can follow along with the map that I have at the top right. I'm going to reference this throughout the video just so you can have a good high-level view of how everything is put together, the changes that I made, and why I made them. It gets kind of complicated looking at just the code, so tools like this, little maps like this, help me at least get a fuller picture and a better understanding of what's going on. So the first things that I want to cover are some of the major changes I made. One to timers, to speeds, and then to the update and the render section. So I'll go through these one at a time here. The timers, I thought that it was a good idea at first to set timers to just some arbitrary value and then decrement each timer by not by a fixed time, but rather by the delta time of the corresponding movement. So for example, for a laser cooldown, I was decrementing by the delta movement of the laser speed. The drone cooldown, I was doing the same based on the delta motion calculation of the drone speed. So it just didn't make any sense, and it was hard for me to tweak and fine-tune how all the timers related to each other. So I thought it was better to express the cooldowns in terms of frames. So the target delta time is the time for a single frame, and now these cooldown times are decremented by a frame. So now I can express the timers in terms of number of frames. So some of the changes that I've made, so the laser cooldown, this is the player laser, it will now be available to fire so we've got a single frame times 30 frames per second is 60, divided by 2 is 30. So that means we've got 30 frames, or roughly every half a second, I'm able to fire a laser. So I'll just write that, half a second. Likewise, I made some changes to the drone spawn cooldown timer. I limited the number of drones available on the screen to 5. It was 10 before, but I found that was just too many. So I tweaked it down to 5. I slowed them down a bit. So that's one of the changes to the speeds I made. I also slowed down the player actually and the player's lasers. I wanted lasers to move a little more quickly than the players, but the players and the drones not too quickly. And I felt that just gave the game a better overall feel. Definitely tweak these on your own and find out what you like best. But the drone's spawn cooldown timer is now every second. So we've got the delta time times frames per second, which is 60, times 1, which makes it every second a drone will spawn up to a limit of 5 on the screen at one time. Now for the lasers, these are the new additions to the game, the drone lasers and that. And before I get into that, I do want to give you a high-level view of how the code is structured, and that'll hopefully help you follow along with the changes that I made. So we'll zoom in on this first part. This image, by the way, will be available in the description or in the top comment. I'll make it available for download. Actually, I'll put it in the code repository, so you can download it there. Hopefully that'll help you. So we have our main Odin file. At the top, we have our constants. We just went through some of the changes at the top right here. Then we have our structs defined, which is our game struct and our entity. Right there. Then we have our main procedure, and below that, other procedures. So our collision check, get delta time, create entities, things like that. In our main section, this is where we have our loop. So we have, setup for SDL, etc., and the teardown. But the loop is the meat and potatoes. So at the beginning of the loop, we check all of our inputs. Then we have our update and render section, which is by far the bulkiest part of our code. Then we have our timers, which we just went through, where we decrement them. Then we have a spin lock. So this is where we enforce our frame rate of 60 frames per second. And then finally, we present our newly rendered screen. Everything we've done with render copy can see that at the bottom. Oh. Render copy. Every time we call that, we're painting something to the new scene, which will then eventually get presented. So that's the bottom part here. Let's go through the update and render section. In part 7, up until part 7, it was quite different than what it is now. So if you want to follow along at this point, I do recommend that you download or check out the branch for part 8. And you can compare to what we're talking about up here. So the old way I did things, first I moved the player and then I rendered the player's new position. Then I would check to see if the player is firing a weapon. If so, I found the first available laser and I would make it available in my array of lasers. Then I would spawn a new drone. So I guess you could say I spawned a new player laser and then I spawned a new drone. So I would add them to the arrays of lasers and drones. And then after that, I would go through all of the lasers again. I would change their position and I would render them. This is also where I did collision detection. That's what I mean by this cool little graphic here. That's my collision detection. And any drones that survived that, I then iterated through that array. I would change positions and then I would render the drones. And so now we had drones in a new position available for the next loop. And collision detection was always based on the visible position of the drone. So that's one of the rules of thumb that I've kind of arrived at. I'm open to having my mind changed, of course. But at the beginning when I'm doing collision detection, I thought it made more sense to me if I was always doing collision detection based on the visible position of the entities, right? So with that in mind, let's go over to our update. So now in part 8, this is how I'm doing my update and render code now. At the top, this is where I'm handling my collision detection. So I first go through my player lasers. I move them and I render them, but at the same time, I'm checking for any collisions with the drones. So let's go up to update and render at the very top. There we go. So you can follow along on the left and on the right. We are right here. I go through all of the lasers. I check to see if the laser is even active right now. If it's on the screen, if it isn't, I just continue. I just skip this laser. Then I go through my collision detection. So for this particular laser that we're looking at in the loop right now, I check that laser against all of the drones. If the drones are not on the screen, then I just skip them. But if the drone is on the screen, I check for a collision. And if there's a hit, the drone dies and the laser dies. And then I break that loop because, of course, the laser's dead. I don't have to keep checking against drones. It can only hit one drone. Next, assuming, well, I move the laser. Dead or alive, I move it. And I check to see if it's still on the window. If it isn't in the window, then I change the health to 0. If the health is 0 because it's died, then I just keep going and I don't get this if block right here. I don't check this one right here. But if it is alive, if the health is 1, then I render copy. So that means I'm rendering it. I'll go over this when hitboxes later. Okay, so that's that part right there. I've checked for collisions. I've gone through all my lasers. I've moved any surviving lasers and then I've rendered them. Next, I go through my drones. So that's down here. I go through my drone lasers, pardon me. Drone lasers. Same pattern. I like to keep the patterns like this. It helps me keep things straight in my head. If the laser is, if the health is 0, then I just continue. There's no point in doing anything with it because it's not even on the screen. But if the drone laser is on the screen, then I need to check for collisions. I need to see if that laser hits the player. If it's the player, then the laser dies and the player dies. Next, I move it. I move the laser. Dead or alive, I move it. And I check, is it off screen? Now these lasers are going on angles, as you can see. Depending on where the player is, they attempt to fire towards the player, you see? So they can go off screen along the x-axis, or they can go off screen along the y-axis. If they're off screen along the y-axis or the x-axis, then I change the health to 0. So the health is 0 either because it's been hit or because it's off screen. And if it is, then I keep going. But if it isn't, if it's still alive, then I render it. Again, I want to stress that I try to keep these patterns the same. You'll notice that the pattern in this block for drone lasers is similar to the player lasers up above. So it's the same thing. I move, render, check collisions. Now, after all of my collisions are handled, I go to this next part here. I check my drones. I go through my drones. I spawn a new drone if I have to. And I fire my drone lasers all in one iteration of the drones. So let's see. I use a respawn flag. Before, I was going through all the drones to render them after I had spawned a new drone. Like, I'd go through all the drones. As soon as I found one that was available, I would spawn it, and then I would break out of the loop. So it was never a full loop, or rarely. Nevertheless, it was two sections where I was iterating through drones. So instead, I just combined it into one and using this flag. I find it a little bit easier to read. It's a little less code. A little, not much. If you find it easier to do it twice the way I had it before, then that's fine. Here, if the drone health is 0, if the cooldown timer is done, and a drone hasn't been respawned yet, then I respawn the drone. Now here what I do, I have 2 different timers for drones. So let's go through that now. The drones have 2 timers because I wanted to make sure that when on the screen, it wasn't only the first drone on the screen that was firing lasers. I wanted to give all drones a chance to fire when they're on the screen. And it looked pretty good in my opinion. I needed 2 timers to do that. So the overall timer, so the master timer or the all timer, goes 5 frames. So every 5 frames, a drone can potentially fire. Every 5 frames, we go through each drone, and each drone will be ready to fire after 120 frames. You can tweak these numbers to get the feeling that you want. But once this first drone fires, it waits 120 frames before it can fire again. So that means the next time this master loop goes, it'll catch the next drone. And once it goes again, it'll catch the next drone. So these drones all have a chance to fire a laser. If you didn't have these inner checks, so if each individual drone didn't have a timer, then that means every 5 frames, this first drone, because it's first in the array, it will be the one to always fire a laser. So you can check that out yourself and you'll see what I mean. Now, when the drone is first spawned, you can see here that I have the cooldown timer divided by 10. So I did that because I wanted a drone to fire fairly early as it entered the screen. I didn't want to wait too long. With the way I had the timer set up, a drone wouldn't fire till it got about to the halfway point on the screen, and I didn't think that it felt that great, so that's why I did that. So let's go back to our update and render. We're here, drone move and render. So once we go through our drones, we respawn, and that only happens once every frame. If the drone health is 0, we just skip it. Then we move our drone. Dead or alive, we move it. If it's off screen, then we just continue. We don't bother rendering it. This is a little different than the check that I did up here. What I could do here is something similar to this. I could do drone health is greater than 1, render. Something like that. There, I like that a little bit better actually. Okay, so if the drone is still alive, we render it. And then after we render it, this is where we check if the drone should fire a laser or not. So we spawn a new drone at the top, right here. Now we are firing our drone laser. So we fire our laser, we look through all of our lasers for this drone. We go through all the lasers, we find the first available laser. And if it's available, we calculate its slope. So the delta X and the delta Y. Unlike our player lasers, they don't go straight to the left. They don't go straight on the X axis. They have to angle a little bit so they can chase wherever the player is at the time. You see how it goes up on an angle? So that's why we have to calculate a slope. Now, we do this with the calc slope function. Just calculate some steps. If our steps are 0, then we just return a 0, 0, which means that our X and Y delta are 0 and 0. Otherwise, we calculate the fractional movements right here and we return them. Cool thing about Odin is we can return multiple values. So you can see I'm returning two x64s right in here. So we return our new dx and our new dy. So that's how I grab them here. You use a comma to separate the values that we return. And then I can multiply those by the laser speed. And ultimately, when we do move the laser, then that's where we get the delta motion. We reset our timers, so our drone specific timer, our overall timer, and then we render. So no longer am I just going through all the lasers in a separate step and rendering each in turn, because then I would miss this one. I render it right here once I spawn it. And then I decrement my drone timer. I want to touch on this a little bit here. This render part. When I'm spawning a new laser, I want to render it right away, rather than wait and iterate over them all later. Just easier to keep in my head. And these renders happen at the end of the update and render function or section of the game loop. And they will then be available once the loop starts over again for the collisions. They will be visible to the player, and then collisions will be detected on them then. If I were to render all of this before the collision, then I could have a collision detected, but nothing would be visible on the screen for that frame. So if I've detected a collision on an invisible laser or drone, for example, maybe I'm counting points. So the points would be incremented, but the player wouldn't actually be able to see whatever's rendered on the screen. So that's why I render all of this at the end here. Next, after the drones are taken care of and drone lasers, we move on to the player. So this is pretty much the same as what we had before. We move the player if the player is alive. Remember, now we're checking for collisions between the drone lasers and the player. So if the player is alive, we move him, we update its position, and we render. And we check for any lasers we have to fire. The player is alive, so the player should be able to fire. We don't fire if the player is not alive, because in that 3-second stage reset, you could still hit the spacebar and continue to fire, which would look a little weird. So that's why we have this part within the health check as well. And at the end here, if the player is dead, then we set the reset. We check the reset timer. We decrement it by the delta time, so the frame. And the reset timer is set for, let's see, how many frames? 3 seconds. So 3 seconds later, this will count down to 0, and then we'll be able to reset the stage. And then at the end of everything, that's where we decrement our timers. So that's that part right there. We just fired our lasers, and then we skip back to our main view right here. This is where we check our timers. Let's cover now this really cool feature of Odin. It's the when keyword, and this is used to compile code optionally. So it's like an if check, but only a compile time check. And so when hitboxes visible is true, which is up here, it's just a little a constant that I made up at the top to flag that. When it's true, then we will render a hitbox around whatever entity we want, whatever destination SDL rect struct. I did this because as I was playing around with this and tweaking things and collision detection in particular, I wanted to better visualize what the hitbox area was like. So how were my collisions being detected? That's why I made this function right here. So we can build this right now. Odin run here. Oh, a little bit of a syntax error. Let's see. Little typo by mistake. You can run this and you can see that there's a little red rectangle around the drone missiles, around the player, and then around my own lasers right here. Can't decide if I want to call them lasers or missiles. Eh? So let's change the size of that screen. I did this just for the demo. Make it a bit bigger so you can look at this one now. There we go. So hopefully you can see that, the red square around everything. And again, that just helped me better debug and visualize the hit areas when I was doing collisions. But I wanted to highlight that really cool Odin feature, the when, and then the next keyword is do. You can see it's followed up by do. So when something is true, you do some expression. to render hitbox. So thanks very much for watching. All of this is available in the repo, so download it and let me know if you have any questions. Cheers.